Hello everyone, my name is 𝐄𝐧𝐠𝐞𝐞, m.tech student at 𝐈𝐄𝐒 Engineering College, and today we are going to discuss about field compaction methods. And there are several methods which are used for compaction in the field using dampers, rollers, vibratory compactors, and other methods of compaction such as vibro flotation method, compaction by pounding, by blasting, pre-compression or preloading, and using sand compaction piles. And the dampers, figure shows a hand-operated damper, or it is also known as rammer, consists of a block of iron or stone about 3 to 5 kilo in mass. It is attached to a wooden rod. The damper is lifted and dropped on the soil to be compacted. A mechanical rammer is operated by compressed air or gasoline power. It is much heavier, about 30 to 150 kilo, and dampers are used to compact soils adjacent to existing structures or confined areas where other methods cannot be used. And for example, it's like trenches behind the bridge abutments, and it is almost used for all types of soils. Next is the rollers, and there are different types of rollers used for compaction, and it depends upon the following factors: the contact pressure, the number of passes, the layer thickness, the speed of roller. And there are three types of rollers: smooth wheel roller, pneumatic tired roller, sheep foot roller. And the first one, as you can see in the figure, smooth wheel roller, and it's a drum tie smooth wheel roller. Generally the smooth wheel roller consists of three wheels, two large wheels in the rear and one small wheel in the front. And this is the tandem type smooth wheel roller. It consists of only two drums, one in the rear and one in the front. And these rollers are operated by the internal combustion engine. And the smooth wheel rollers are useful for finishing operations after compaction of fields and for compacting granular base course of highways. And these are not effective for compaction of deep layers of soils, as the resulting compaction pressures induced are low. And further, these rollers also cause stratification in deep layers due to non-uniform compaction. And next is the pneumatic tired roller. As shown in the figure, it has rollers used compressed air to develop the required inflation pressure, and the contact pressure depends upon the area of contact and the inflation pressure. The roller generally consists of 9 to 11 wheels fixed on two axles, as you can see in the figure, and with the pneumatic tires so spaced that a complete coverage is obtained with each pass of the roller. And the rollers are available in a wide range of load sizes. The inflation pressure varies between 200 to 1000 kilonewton per meter square. And the rollers are available as a self-propelled unit as well as towed unit. The roller compacts the soil primarily by kneading action. That's the main thing. Next is the sheep foot roller. And the sheep foot roller consists of a hollow drum with a large number of small projections. You can see in the figure, small projection, like it is like a feet of a sheep, and on its surface. And these projections, you can see in ancient time before the advent of these rollers, it was usual practice to pass a flock of sheep on the newly formed soil field to cause its compaction. And the same principle is used in the design of sheep foot rollers. These projections penetrate the soil layer during the rolling operations and cause compaction. compaction. The drums are mounted on a steel frame, and the drums can be filled with either water or ballast to increase the mass. And the sheep-foot rollers are available both as a self-propelled unit and a towed unit. As rolling is done, most of the weight of the roller is imposed through the projections of the on the soil. And the sheep-foot rollers are ideally suited for compaction of the coarse soil. And the rollers compact the soil by combination of tamping and kneading action. The roller is passed for the first time. The projections they penetrate the soil layer and the lower portion of the layer is compacted. And in successive passes, the compaction is obtained in the middle and the top of the layer. And the depth of the layer that can be compacted depends upon the length of the projections and the weight of the roller. Small rollers can compact layers of 15 centimeter thickness, whereas heavy rollers can compact layers of 30 centimeter thickness. The next is vibratory compactors. In vibratory compactors, vibrations are induced in the soil during compaction, and the compactors are available in variety of forms. And there are two different types of vibratory compactors. One is the vibratory roller and vibrating plate compactor. When the vibrator is mounted on a drum, it is called a vibratory roller. These rollers are available both as pneumatic type and smooth wheel type. And in the figure you can see a smooth wheel type. In smooth wheel type, a separate motor drives an arrangement of eccentric weights to create a high frequency. And these rollers are suitable for compacting granular soils. However, there is appreciable percentage of fines. The thickness has to be reduced. In pneumatic type, as you can see, and vibratory compactor, a separate vibrating unit is attached to the wheel axle. And next is the vibrating plate compactor, and shows the figure. And this system, there are number of small plates, and each plate is operated by a separate vibrating unit. Usually gasoline or diesel engines drive one or two eccentric weights at a high speed to develop a compaction force. And the effect of the vibrating plates is limited to small depths. Their main use is to compact granular base course for highways and runways, where the thickness of the layers is small. And the main the main advantage of this vibratory compactors is to compact it can compact granular soils to a very high maximum dry density. And the next is vibro flotation method. The vibro compaction is also known as vibro compaction, and as you can see in the figure, the vibro compaction in action. And it's also it is a technique in which the density of granular soil are increased by insertion of heavy vibrating poker to a desired depth. And this vibrating poker is also known as the depth vibrator or a vibro float. And it is one of the most common ground improvement technique using vibration. Water flushing is done during the insertion process. The vibro flotation is most suitable for very loose sands submerged under water table. Efficiency of densification reduces with increase in silt and clay content, and penetration rate reduces in case of dense sands with deep water. Next is the principle. And the vibro float, the The figure shows the vibro float imparts horizontal vibrations into the ground to break down the frictional contacts and effective stress between soil structures. Thus, ground settles into a denser structure as shown in the figure. And it's the compacting action of a vibro float. The figure shows in the first part at a full water pressure, the vibrator penetrates to design depth and is surged up and down as necessary to agitate sand, remove fines, and form an annular gap around the vibrator. The second part shows once at depth the water pressure is reduced and with vibrator remaining in ground, sand infill is added from ground level and compactor at the base of the vibrator. And the third part shows that when the required compaction resistance is achieved, the vibrator is raised and the more sand fill is added and compacted as before. And this procedure is repeated until compaction point is built up to ground level. And the vibro float imparts horizontal vibrations into ground to break down frictional contacts. The ground settles into a denser structures as shown in the figure, and the soil structure it is breakdown under dynamic stresses around 0.5 g, and when the acceleration is increased to about 1 to 1.5 g, the shear strength is decreased and the ground becomes fluidized, and the further increase to 3 g will lead to dilation of the soil. The accelerations imparted by the vibrator decreases with the increase in distance. The level of compaction is lesser near to the compaction point. And for successful compaction, the ground should drain freely. And with increasing the slit content in ground, the shear stresses are not effectively transferred. And the vibrating poker, the description of the vibrating poker, it consists of three parts, and mean the vibrating unit, the follower sections, and the lifting head, and the penetration of float during the initial boring is supported by the compressed air or water jets. The compaction of the ground is done in vertical steps of about 0.3 meter, providing sufficient time at each stage to maximize degree of compaction. And the applications of the vibro-compaction are it is applied to improve hydraulic fields and reduces the risk of liquefaction during seismic event, and it's used over water, and the depths of 30 meter can be treated and can be up to 50 meter, and also the multiple vibrators can be coupled together in groups, and vibro-compaction is used in conjunction with surcharging. Next is the limitations. The vibro-compaction is not effective where the fines and silts and clay exceeds 20%, and the coarse grain limit is applicable to vibro-compaction and cannot be applicable to low permeable soils. Next is the compaction by pounding or dynamic compaction. The figure shows the dynamic compaction action, and the dynamic compaction is a ground improvement technique in which a drop weight is used to densify the soils and the fill materials. The drop weight is typically made of steel and is lifted by a crane and repeatedly dropped on the ground surface. The vibrations that are resulted from the repeated drops are transmitted below the surface, with which improves the soils at depth, and these drop locations are generally located on a grid pattern, and the subsurface conditions and foundation loading determines the spacing of the grid pattern. And the dynamic compaction utilizes the dynamic effect of high energy impacts which are caused by the drop weight of steel, and these large steel waves weigh 15 to 40 tons, which are dropped from a height of 10 to 30 meters. And the actual purpose of the technique is to transmit high energy waves through the compressible soil layer to improve geotechnical properties of the soil at greater depths. And the dynamic compaction is normally associated within an intensive procedure which undergoes in situ testing to verify the specified improvement has been achieved. Next is the compaction by explosives. As the figure shows, the blasting in action, and the it involves placing a charge at depth in a borehole in loose soil and then detonating the charge. It is generally used in sands to silty sands or sands and gravels. Several sorry, charges are fired at one time with delays between each charge to enhance cyclic loading while minimizing peak acceleration. Often, several charges will be stacked in one borehole with gravel stemming between each charge to prevent sympathetic detonation, and only small scale equipment is needed to minimizing mobilization cost and allowing work in confined conditions. And buried explosives are used to densify coarser soils. The shock wave and the vibrations produced by explosives are somewhat similar to that produced by vibratory compaction equipment. The method is quite effective when the coarser soil is fully saturated. The shock waves cause liquefaction of the sand, which is followed by densification. And in partially saturated coarser soil, the compressive stresses develop due to capillary action and prevent the soil particles from taking closer positions. The depths up to which the blast is effective is limited to about 25 meter, and the uppermost zone of the soil up to a depth of about 1 meter gets displaced in a random manner and therefore not properly densified. This zone should be compacted using the conventional methods by rollers. Next is the pre-compression or preloading, and the figure shows the preloading and ground improvement in soil pre-compression in Kuwait. The soil pre-compression is one of the ground improvement techniques which compresses the ground under an applied pressure before placing or completing the structural load. And the pre-compression is performed in the following two ways. The ground pre-compression is achieved by preloading, which requires placement and removal of earth, water, or some other dead load before construction, similar in weight to the final load. And surcharging is where the stress intensity from the preloading is greater than the intensity from the final loading. And the ground improvement with soil pre-compression. The pre-compression of soil is used to induce settlement that have three recognizable phases. That is, first is the immediate, and the pre-consolidation, and the secondary consolidation, or it is known as creep. And in loose fields with large voids, the potential for immediate settlement can be very high proportion. Next is the preloading and surcharging soil. The preloading soil and surcharging usually involves placing an earth fill over quite a large area or over several areas within one site. For full economy, the fill should be reused materials which are used to form. The load can be earth fill or rock fill, water, or any other easily transportable and available backfill. And on settlement under the preload, is completed, the preload is removed, and then the construction of the structure is started. And in general, the area of the final structure is less than the preloading area because stresses produced at any depth in the foundation soil are uniform, and it should be equal to or greater than the final stress produced at the location. The limitations of preloading and surcharging: insufficient time available to achieve the um, 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 sorry the required compression or pore pressure dissipation, and excessive lateral deformation of the pre-compression fill, often because of the transmission of the high pore pressure, inadequate factor of safety against shear failure when the structure is complete. It is essential to check the stability of this stage, and the final post-construction settlements may be greater than expected. And to the final slide, the sand compaction piles. And the figure shows the sand compaction piles. Sand compaction piles are one of the potential methods for improving ground stability and preventing liquefaction, reducing settlement, and similar applications. The bottom is closed with a collapsible plate down to the required depth, and then pipe is filled with sand. The pipe is withdrawn while the air pressure is directed against the sand inside it. The bottom plate opens during the withdrawal, and the sand backfills the voids created earlier during the driving of the pipe. The sand fill prevents the soil surrounding the compaction pipe from collapsing. The pipe is withdrawn. During this process, the soil gets densified, and there are two types of sand compaction pile method depending on the system deployed. First one is the vibratory system with vibro hammer, and the other one has a non-vibratory system which forced lifting or driving device, as you can see in the figure. It's a process of sand compaction piles method, and the vibration sand compaction piles are developed 50 years, but the vibro hammer used in this method has a negative effect in the form this method has a negative effect in the form of vibration noise to the surrounding environment, which makes it difficult to use this method in the urban areas or locating close to existing structures. To avoid these problems, this method is utilized a system with a non-vibratory sand compaction pile method was developed, which does not require impact or vibrations on the driving device to penetrate into the ground. And the equipment consists mainly of a sand compaction pile driving device used as a base machine, as a force lifting device with a rotating drive motor to rotate the casing pipe, and the non-vibratory sand compaction method, they set the casing pipe to the predetermined place. By operating the force lifting or driving device, install the casing pipe into the ground while rotating. The sand is fed through upper hopper after the pipe has reached the required depth, and the casing pipe is pulled up, which results in the sand being pressed out to the void by compressed air. The casing is then extracted along with the compaction of the pressed out sand piles so as to enlarge it. Above procedure is repeated till the sand piles are formed to the ground surface. Thank you.